We will wait 2 more minutes and start the session. I hope all of you can visible the slide. So today we will So today we will start this our second tutorial class based on the second week of the course. Okay. So second week are taught microscopes, microstructures, and quantitative metallography. So in that, okay, optical microscopy, there he taught us magnification, useful magnification, resolution, depth of the field, and depth of the focus. So I like included the most some of the important part from SARS class here. So we are going to solve problems based on this and based on the assignments also. That's why I included this part here. So if you see here in this, it's a like what we call compound microscope. Okay, so here the object will be there and there will be a objective lens will be there and a condensed lens, so light source will be there and aperture here. So from the aperture to condensed lens will pass first to the uh, mirror, then from the mirror it will go to the objective and it touch the object and it will reflect here and focus on the back side of the mirror and the light will go to the eyepiece. So the here we can see the object as a magnified form. Okay, so if you want to increase the magnification you have to more lenses you have to use. Okay, so that's the main thing. And in the class I told about the normal very basics parts also, like in plus 2 courses whatever you have learned for the normal light lens working also, how where will be the object and the light passing direction and focus direction. So that kind of problems also we will solve here today. 2-3 problems we will solve according with that. Okay, and after that he discussed about the resolution. So resolution and resolving power, so there is a relay criteria for that. So how we can differently uh, see two distinguished light sources. So there will be a minimum distance between them. So what is the distance, and also that is the Rayleigh criterion, that we can call it as a resolution limit. So it will be d1 by 2. So d1 is the here from the minima to next, like from one minima to next minima, what is the distance? So that is the d1. So half of it will be the resolution limit, and by using a wavelength and alpha and mu value, we can write it as r1 is equal to 0.61 lambda divided by mu sin alpha, and here lambda will be the wavelength and mu is the refractive index and alpha is the half aperture angle. Kaushik, can you please mute it? Yeah. Okay, now that is the resolution. Now depth of focus is the range of position at which the image can be viewed without appearing out of focus. So it will be change the distance of image formation is equal to minus m square h, and it will be magnification, and h will be the depth of field. Okay, and what is depth of field? Depth of field is nothing but the range of position for the object for which our eye can detect no change in the sharpness of the image is known as depth of field. And h we can write it as in terms of again lambda, mu and alpha. So here also lambda is the wavelength, mu is the refractive index, and alpha is the half aperture angle. Okay, half of the aperture angle. And what is aperture angle and everything are already discussed in the class, so I just gave the brief idea like what we have to going to do in this live section. Now if you move on the first question, okay, these are some questions which I took from the last year assignments also. So the first question, so let it be interactive mode. What is the answer for the first question? Mode of illumination in the metallurgical microscope is?
Reflection?
Yeah, reflection. What about the biological microscope then? That was the starting
Uh,
class, right?
it is transmission.
Yeah, transmission. Yeah, correct. So here,
Marginal ray focuses away from the lens.
no, it's not away from the lens. So the first question answer is reflection, and marginal rays focuses on nearer to the lens. Okay, that's also sir taught in the class, right? If you have, and the margin rays, if it is coming from here, it will focus near, the other rays will focus in the back side. So this will be the more one nearer to the lens. Now achromatic are corrected chromatically for dash kind light. Which kind of? That's also in class discussion. It's also happened in class discussion. Anyone remembering?
Green is there, I think. Also, green.
No, no. Green for fluorides.
Oh, green is for fluoride. Okay.
So it will be red and blue.
Okay.
So obviously the next answer, fluorides are corrected spherically for blue and green. And next question. Single crystal is preferred for applications where we would like to have lower creep deformation, lower fatigue failure, higher yield strength, and higher UTM. Which is what is the answer?
Is it B?
Yeah, it is not
Low,
B. It will be lower creep formation.
lower creep. Single crystal.
Huh. Yes.
No,
Was
generally,
it?
sir mentioned this one. Generally, the single crystals are preferred in turbine and all that. So there it is like fatigue loading, and single crystals are generally prone to more creep deformation. As far as I remember, I may be correct.
Okay, let me cross check that. Okay, because the answer but I think it is A. But okay, I'll cross check that once again. And what about the sixth question answer? ASTM standard for volume fraction measured is
These
A.
questions like 6 and 7 will be asked in exams standards. Like very difficult. This one to.
These are assignment questions, earlier assignment questions. I don't know this
Okay.
year it's given or not, but it was
Okay.
earlier years. But these are discussed in the class, right? The values just.
Yeah, yeah. No, no, they are discussed, but okay.
So here the answer will be C. E56311. And what about the seventh question answer? Standard for grain measurement is
I think linear intercept. Oh,
no.
oh, sorry. STM
B is the answer. And method to measure grain size of a material is
linear intercept.
both B and C. There are circular
Oh,
intercepts also, and as
okay.
well as linear also. Now, now what is the correction factor to get the grain size from the linear intercept length for a tetracaid decahedral shape veins? Anyone remembering the answer value? It will be 1.776. See, these are the earlier year assignments questions. Okay, so what happens? So see, these kind of questions only will come for your exam. So whatever the things sir is discussing in the class, you should remember them. Okay, even it's a small minute thing also, but it will come for the exam.
And we have to mark up all these values.
Yes. Like for
Actually, one more thing. Actually, in last class, we have discussed about this theta 1 is to theta 2 is to theta 3. You will say that you will provide something. I mean,
yes, that will be in S.O. Pillai. Solid State Physics book by S.O. Pillai is there. Like,
that means that I have for solving one problem, I have to read one book. I mean,
no, but
नहीं नहीं आई मीन कैन अंडरस्टैंड नहीं ये थोड़ा कुछ हैंड आउट टाइप पे या फिर फोटो ये भी
okay,
चलेगा
okay.
ना
You want the note, like handwritten note for that? Oh, I thought only
हैंड
the.
रिटन नोट या फिर मतलब जितना मिनिमम पॉसिबल है हाँ
Yeah. Okay. I will provide it because I thought you only need the textbook. Okay, fine. Because in the textbook it's clearly written, but it is little bit lengthy, like the theory part. Hello, are you able to hear right?
यस
Yes, fine. Okay, I will provide the notes in a slide next time. Like I will keep the photo of that. I think that will be better. And I can share it only through these online classes. So what I will do, I will share it in the next class. I cannot keep it in the Swayam portal. And here you have to remember the values and the concept very correctly, otherwise it will be problem for you, like for your marks. Okay, and these are like last time I didn't included any options, but for your case there will be options for you people, so it may be confusing options also, so you have to solve it and find the answer for all that. Now see the 10th question. It's a very basic question. Calculate the resolution of a microscope in micrometer with lambda is equal to 400 nanometer and refractive index which is given mu is equal to 1.7 and numerical aperture that is 1.6. So which formula we have to use for this? Can anyone tell? So we have to use here resolution is equal to 0.61 lambda divided by mu sin theta. So lambda is given, sin theta is given, lambda is given, and what is given? Mu, refractive index is given, and numerical aperture. So what is numerical aperture? Numerical aperture is mu sin theta. Okay, so sometime it will be like this. So you can directly take the value 1.6. No need to go for the refractive index value because theta didn't given in the question. So what you have to do, you have to take this as whole mu sin theta is equal to numerical aperture value, substitute that and find the answer for the resolution.
Option C.
Yeah, option C is the answer. So it will be 0.16 times 0.4 divided by 1.6. Now we have to go for the next question. The question is, what is the minimum separable distance between features?
Sorry, one thing, just last page you go, please. This aperture, when you say na numerical aperture, it will be like a length, na.
Yes, yes.
So this generally mu sin theta, when we say it, what is the unit?
Like normally it will be in the length unit.
No length unit, but okay. See here,
Both
say,
don't have units.
say
So it's like
1.6.
an arbitrary units we are taking numerical aperture. Mu don't have refractive index, don't have any unit. You know, right?
No, okay. Say one thing. This resolution, whatever came out, is it having some units? Is it?
Resolution, no.
Nanometer, na? Sorry,
No, then mu.
in micrometer, na?
it will
Oh,
be
mu sine theta is unit less than.
mu sin theta is unitless.
Oh,
Then you
okay,
will call
okay.
it as arbitrary unit. But if
Oh,
we say
okay, okay,
actual
got it.
aperture, what is the
Yeah, yeah.
distance?
One.
But
It is. I think that it is. Is it same that 1/f?
it won't be same as 1/f.
Generally, in lenses we talk na aperture 1/f actually.
Aperture
DSLR and
then
all that we. Is
that
it
is
same thing?
same thing. Sir also told that in camera and whatever combat mode microscope everything will be same.
Okay, done.
Yeah.
So, okay, it is basically you and whatever resolution, whatever
Will
answer
be
is
the
coming, it is the units. It will take
wavelength
the
of
units of
length.
the wavelength. Okay, done. Thank you.
So in the next question, what is the minimum separable distance between features that can be resolved by a microscope using the light of 5 nanometer wavelength having refractive index of lens is 1.9 and aperture angle is 150. So how to solve it this one also?
Tell me one thing, this aperture angle is alpha or 2 alpha?
What? Aperture angle is? Alpha.
Alpha or 2 alpha?
Alpha means aperture angle which
That
is given
is
is total.
75. We have to
Your
take.
half of that you have to take.
No, no, I mean when we क्या I mean 2 alpha को क्या बोलते हैं? Then 2 alpha को क्या बोलते हैं? I mean, can you understand what I'm
Then
saying?
aperture angle is alpha and our equation sin theta that will be the alpha by 2.
Okay, fine. Okay,
Semi
fine.
aperture angle.
ठीक, semi aperture angle.
Yes.
तो okay. This alpha by 2 is basically semi aperture angle.
Yes, correct. So what is the minimum separable distance between the features that can be resolved by a resolution, let's say by a microscope? That is the resolution value. So you have to find the resolution here. For that you know already formula, you have to substitute all the values here. Here aperture distance is not given, so what you have to do, you have to substitute all separately, lambda value, mu value as well as theta value also separately.
C.
Option C, yeah.
C.
So you have to substitute all the values, 0.61 lambda divided by mu sin theta, it will be That will be the answer, 0.166. Okay, so these are the basic questions, and now we will solve some questions also, like mm, limit of resolution and etc. Okay, so see this question: the limit of resolution of the microscope if the numerical aperture of the microscope is 0.12 and the wavelength of the light is used is 600 nanometer. So what is the formula for this? Resolution limit will be lambda divided by 2 mu sine theta. Okay, so see the question here. What are the values are given? Numerical aperture value is given and wavelength also given. So lambda is given, that is 600 nanometer, and mu sine theta, that is numerical aperture, that's also given 0.12. So you have to just substitute the value to find the resolution limit.
Sir, what is this formula?
No, it's for resolution limit. At max, what?
Oh, resolution limit is d1 by 2. That's okay.
Yeah,
Your
same way. So, but
It is not in the slide. I mean,
it is not in the slide, but some problems are there in the earlier events related to
oh,
this.
okay, 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 fine, fine, fine.
okay, resolution limit.
There are some formulas like that which is not in the slides also, but can possible to ask in the exam. Like same kind of theory.
It is giving quite high value, 2500.
2500 in which unit?
Nanometer.
2500 nanometer.
अगर मान लो ए 2 है ए 3 है इसकी वैल्यू 4 है तो एस की वैल्यू कितनी आ जाएगी 2 + 3 + 4 अपॉन 2 तो नहीं कैसे कैसे हो जाएगा ये एडिशन में है मल्टीप्लिकेशन में नहीं है ये सारे
Sir, one more thing, that one formula was there, R1 equal to D1 by 2.
Yes.
What? That was also limit. What was D1 in that?
Oh, D1 is the like. Do you remember this?
plus 2 3.2 yes absolutely correct तो 1 plus
Length is
d
1
upon
and the distance between
4
these
upon
two is d1.
so 1 plus
One minima to another minima. We
Oh, okay,
cannot
okay.
measure it, right?
Done.
It's very
Okay, okay.
difficult. That's why wavelength and
So
intensity.
that formula is not being used over here. R1 equal no.
It is very difficult to measure what
Done.
is the
Okay.
this is the better
distance between two minima or maxima for this.
Then the answer will be 2500 nanometer.
Nanometer. What will be in the micrometer?
x की वैल्यू आ गई
With everything we are saying is a micrometer unit, right? So everything you have tried to convert it into micrometer. Okay, I can give some options
So
here.
2.5.
225.
It will be 2.5. Yeah.
2.5.
upon
Sorry, yes, 2.5.
when you will solve that
So if you substitute all here, so 600 divided by 2 times 0.12. It will be nanometer. So you will get 2500. And so what is the resolving power of a microscope?
It shall be same as resolution only, no?
Yes. So what will be the formula?
R1 equal to the 0.61 lambda by mu sin theta.
Resolving power is like, yeah, but you have to write like resolving power will be so here also it's all the values are given, just you have to substitute.
How many formulas are there?
There are related to this, there are 2-3 formulas are there. You have to by heart it in other way. Because lenses are a very complicated system, so for each type there will be different formulas. Even for compound lens, magnifying power is different value, and image distance, to calculate image distance, focal length, that all we in first slides are showed 1 by u plus 1 by v is equal to 1 by f, those formulas, right? So related to that also some formulas are there. but this is at least like just we have to apply the formula in this session, that's it. If you see the last week second week classes, only this portion is related to the problems, all others are theory part. So theory part, whatever are taught in the class, that only will ask, even it's a small point also, that can ask in your exam. But problem section you have to solve it in different ways. So like last week what we discussed, like this crystals, planes and all, right? So that is little bit more important, like what to say, little more difficult, like to find the solution. But here if you know the formula, just apply the values, you will get the answer. And definitely there will be option for these cases because unit is very important. So like that.
This is 0.04 per micrometer.
Yeah,
What is actually the resolving power, like
it is same as
what
like
significance?
resolution.
Cannot be because the units are exactly
Hmm.
uh,
Length unit, inverse of length unit.
inverse. Yeah, so that's what.
And the main, do you know what is the main factor which affect the resolution or resolving power and all? That also are discussed, right? Even are discussed, I think, like the lens power also, like normal our lens power also mainly depends on the refractive index of the medium. So here this question, the limit of resolution of the microscope if the numerical aperture of microscope is 0.2 and wavelength is light used by 600 nanometer. This is very easy problem.
Point 915.
How much you got?
0.915.
1955. What you took the refractive index?
15 micrometer.
No.
Resolution limit equal to lambda upon 2 mu sin theta, na, right?
0.6.
0.61 lambda by mu.
Sin theta.
So numerical aperture is given, that is mu sin theta, right?
Yes.
So 600 divided by 2 into 0.02. Oh, okay, sorry, 0.2. 2. Wait.
Sir, it is coming 1.8.
No, oh, 1.8 it cannot, it will be somewhere in the multiples of 15, 1.15 only.
15.
Because see, bottom it is 2 and mu sin theta is 0.2. and top it is 600. So 600 divided by 4, you say, it will be
Ah,
coming
ha, ha,
50.
ha, ha, ha.
Okay, so and that only
Ah,
that
right,
micrometer,
right, right.
nanometer, okay, we have to adjust actually.
Yeah, yeah, thank
That is
you, thank
only
you, thank
creating
you. It's a
confusion.
very nice tricks.
So it will be same as this formula.
No, this is resolution, na, sir. You are asking now resolution limit.
Yes, yes. This one.
So this will be the lambda upon 2 mu sin theta.
So lambda divided by 2 mu
Body.
sin theta. So substitute all the values. Lambda will be 600 nanometer and mu sin theta, that is numerical aperture, 0.2. So it will be 600 times 10 to the power minus 9 divided by 2 times 0.2.
1.5 micrometer.
Oh, maybe 1 times 10 to the power 9, it will come 1.5. So do you know about compound microscope? Like the same as whatever we discussed, same way, that is only compound microscope. So see this question, the total magnification produced by a compound microscope is 20. The magnification produced by the eyepiece, and magnification is for the magnification time that for the lenses, right? How much it is magnified. So for the eyepiece it is 5 and the microscope is focused at a certain object. The distance between the objective and the eyepiece is observed to be 14 centimeter. If the least distance of distinct vision is 20 centimeter, calculate the focal length of the objective and eyepiece. So first it is a little bit, it is very easy problem but little bit lengthy problem. So okay, let us draw first. Okay, so there will be okay, so here the object will be that. So what are the values are given? Total magnification produced by a compound microscope. Total magnification we can write it as m. Okay, so that is given 0. So for a compound microscope, magnification will be magnification of eyepiece times magnification of object. Okay, so the total is given 20 and the magnification produced by the eyepiece, so m is equal to 5. Okay, and the length, the distance between the objective and the eyepiece, so this is objective and this is eyepiece, so the length which is given, L is equal to 14 centimeters. So L is given 14 centimeter. Okay, now the last one, if the least distance of distinct vision is 20 centimeter, that we can take it as D. Okay, we have to calculate focal length of the objective and focal length of the eyepiece. So in this case you have to remember two formula. One is for a magnification of eyepiece, the formula will be 1 plus D by Fe. Okay, and that formula which you remember for other case, the magnification of objective is V by V0, V by U0. Okay, that already taught in class what is the magnification of normal lens. So that you can write it as L by minus F0 also. Okay, because the minus is coming because if the ray is going this direction it will be positive, and if other direction you have to consider negative. So object will be backside, so that's why every time it is coming mu 0. And for a normal like compound lens, the objective, the focus will be in the back side of that, so that's why focal length of the objective will be minus. So if you know these two formula, you can solve this problem. From here you will get Fe value, from here you will get Fo value. So these three are very important formulas in this problem. So if you see the first case, what will happen? M is already given, right? That is plus 5, which is given. That is equal to 1 plus distance is 20 divided by Fe. From here you can calculate the Fe value. And the second case, MO is not given, but from this you can understand what will be the MO value from here. So it will be M divided by ME. M is given 20, ME is given 5, so MO value will be 4. Now that you have to substitute MO is equal to L by minus F0, and L is given, so it's a direct substitution.
Minus 5 and plus 5.
Plus 5 for what? Fe or
F naught. Fe negative.
No.
Me equal to Me was 5, na? Yeah, 1 plus d by Fe. So, oh no. Okay, got it. It will be plus.
The fee is fine.
Fe is 5. What about Fo?
Fo will also be 5.
3.5.
See here, one thing you have to remember, MO will be negative value. So your case will be negative.
Minus 3.5.
No, that's what. 3.5 is the answer. Magnitude is 3.5. The direction will be minus.
Minus. Sir, can you explain it once again? It is quite complex. I mean that.
This no, how you are telling MO will be negative, like MO will be positive, na?
No. Some cases
Why?
MO will. See this formula? Here it is very clear, right?
M equal to Me into MO, correct, na?
Yes. But that is for the magnitude. The direction, how you can say, with the
Oh, in magnification also direction will come.
yes, yes. Magnification can be negative and positive also. Most of the cases magnification is negative, but in this problem it is coming positive.
Can you explain it once again? ये प्रॉब्लम को थोड़ा फिर से एक्सप्लेन कर सकते हैं क्या?
Yes, 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 fine. Like this problem for a compound microscope. Okay, combo microscope have objective and eyepieces, right? So when like light coming from the objective, it has to reach to eyepiece. So from there the magnification is happening. So what will be the value of the magnification? So each lens has magnification. I think saw that m by view. Okay, magnification is the normal formula is m v by u. V by u is the formula for the magnification for a normal lens. Hmm? But in the case of compound lens, there are two kind of lens, compound microscope. One will be the eyepiece lens and another one is the objective. Okay, so for the total magnification will be the multiplication me times mo. So that is the one important formula. Now here the values are given is length. Length means length between the objective and eyepiece, and another is given distance. Distance, the least distance is the least distance of distinction, so that will be 20. So we have to get a formula which includes L and D value, then only we can find it. So
Isha, what is the meaning of this least distance of
distinction means if you like in compound microscope, if you move the eyepiece, like we have to focus it, right? So the least, that is the which least distance you can distinct the object properly, like all the edges and everything very clearly, like where is
Okay,
the
okay.
focus length, that's it.
Hmm. Okay, focus length.
Yeah, there will be a minimum distance to you can see the it clearly. After, if you go after that, you cannot see the clear image of the.
The positive, negative, what is this positive and negative means in
Positive
this
and
figure?
negative is like always in the case of lens. What will happen um, if this is your focal length and the right side of it will be positive and the left side will be negative.
अच्छा.
Okay, so your objective always will be the left side. For some,
Objective will be on left side. Okay.
okay, like normal length, like your object will be the if you see what is the normal length lens. Okay, there is a single lens. Okay, your
Hmm.
object will be the left side and light passing through it and it will focus
अच्छा.
somewhere here, right? So this will be
Okay.
the negative and this side will be the positive. So what will happen, that with respect to this here, it the u, your u value, u is the distance between object and the lens, so u will be negative value, and image it is depend where it will form. Sometime your image will be back side of the mirror, then it will be negative, and if it is the front side of the mirror, it will be positive. Same way here also, in case of compound microscope also, I will keep the figure. Okay, if you say compound microscope, how it will work first? Okay, we have some object here. Hmm? Our objective is here. Okay, so now light passing through the object, it will go here and it will go somewhere here. Similarly, another light ray passing through the center of the objective, it will be somewhere here. Okay, so the image will be present here. It will be inverted image. Now our eyepiece will be there, right? So this is objective, and we have to look through a eyepiece. So our eyepiece we are keeping here. So what will happen from this inverted image? Light will go to the eyepiece, right? Light will go like this also. So we can see from this side. Hmm? So from seeing this side, what will happen? Our image will be forming the back side of the mirror somewhere. Are you getting?
Mm-hmm.
So the our image size will be this much bigger. So the actual object is very small, but whatever we are seeing is a magnified image. So this is the amount of magnification from this size to this size. How much it is magnified? That is we are measuring. Okay.
Okay.
So see here, what happened? It formed the back side of the eyepiece, right? So the magnification is negative. This is the eyepiece. Okay. But these all things, without drawing all this, we can get it from the formula actually. That's what we are doing here. So for in
Fine.
this problem, so what you will get the answer here then? Ft value, it will 5 minus, it will be 4 is equal to 20 divided by Ft. Ft you will get it 20 by 4, that is 5. Okay. Mo value will be
This unit will be in centimeter. Okay, fine. It is
yeah,
20 in
centimeter only.
both. What will be the dimension
Same,
of
same,
this?
same, same, same. All will be in centimeter.
Oh, both are in centimeter. Okay, fine.
Yes, ma'am.
Yes. There will be one more part also you have to know. Okay, let us go for the next problem. We'll discuss. This problem, the separation length L between the objective and the eyepiece of a compound microscope is 7. Where should a small object is placed that eye is least trained to see the image, and what is the angular magnification produced? So how to find it? So you know that for a lens the formula will be 1 by V minus 1 by U is equal to 1 by F. Okay. F0 will get. And angular magnification will be V by U times D by Fe. Okay. D value here it is 25. Okay. So see the question, the separation between L. Okay, that one. You have to find the where should a small object to be placed that the eye is least trained to see the image. Okay. So the eye is least strained means if the final image like after the eyepiece like that image should form in the infinity like far distance. So in such cases what will I do? Image formed by the objective should fall at the focus of the eyepiece. So where is the eyepiece focus?
This how well from where the D equal to 25 coming?
No, that's I wrote. I forgot to add in the question. It is there in the question. So if you want to get the least distance, the what you have to do, you have to the image should form whatever here the image came. The image should form in the focal length of the eyepiece. Okay, then only we to till that distance the very least like according to the question like without straining your eye you can see the images. So that is the condition. So here the things are given. FO is 5 centimeter and L is 7 centimeter. then the image will form V will be where it is 7 minus 5. So it will be 2 centimeter. Okay, so 2 centimeter from the objective, so it will be positive 2 centimeter. Now if you apply the formula, 1 by u will get 1 by v minus 1 by f0. So from there you will get the u value. Okay, from the u value you have to substitute here. All other parameters are given. You have to substitute the formula, you will get the angular magnification. So only one condition you have to know: the eye is least strained if the final image is formed infinitely. So such cases, what you have to do, the image formed by the objective should fall at the focus of the eyepiece.
Can you explain it once again? I mean, it is not that much clear to me.
Yeah, okay. So this is the lens formula that I think sir already
Okay,
shared
okay,
the
that is
note,
fine.
right? And angular magnification is we have to find from the known values, like measurable values. So measurable values are image length and objective distance, and d is the length which is given, and f is the focal length. Okay, like whatever we discussed earlier here, the same d value, l value, and all. Okay, least distance, length, etc. So what we have to do, we have to get the first one, we have to get the u value, like objective distance, and then we have to find the angular magnification. So for getting the object value, like here we have the focal length and the total length, that is the length between the objective and eyepiece. So this length is given. Okay, and the focal length of the objective is 5. So objective focal length means here is the objective. Once this is the objective, so objective focal length will be coming somewhere here, right? And the remaining length will be the eyepiece length. So where should be the eyepiece focal length? Because the criteria is, if you want to see the least vision, like least length without any strain, the images of the objective which is focused in the same place the eyepiece focal length should come. That
Sorry,
is,
say again.
no. The criteria is what? The least strain, this final image formed in such case, the image formed by the objective. Okay, that is here. This is the objective, image formed by the objective should be fall at the focal length of the eyepiece. So both should
Okay,
be
fine.
same. The image formed by here, this length only should be the eyepiece focal length also. That's why we use this criteria here to subtract. Okay, the remaining length only will be the image length. So till this, what will happen? It will be focal length of the objective, right? Total length is L. So this will be the image formed by the eyepiece also. So this will be the V value.
Mm-hmm.
Okay, and with respect to objective, this is going this direction, so our V is in right side, so it will be positive. Okay, so that's why V value is positive. Got it?
In the in the question you have given f naught as 0.5 centimeter.
Oh, what it's not as visible here. This is FE.
So objective should be f naught, right?
Objective should be F. Okay, so the representation is
Your presentation is wrong.
yes, yes. Here this is F only, but focal length generally representing as a f4. That's why it is written objective focal length is 0.5 and eyepiece focal length is 5 like that. But you have to we can represent it separately. F4 will be 0.5 and FE will be 5.
In that one, U will be minus, no?
Which will be?
U?
U will be minus.
What is the value of V?
V, how much you are getting? 2 centimeter.
So U is half centimeter. Sorry, not half centimeter.
2 by
7 minus 5
0.66.
or 7 minus
Yeah, 2 by 3.
2 by 3.
Yeah, this positive, negative, these things are quite confusing. I mean,
That is with respect to which length you are considering. It's accordingly like that.
hmm. Okay, fine. Is it with respect to the object or with respect to the lens? I mean, which one is much more convenient?
Objective. Not object. Objective with respect to the lens.
With
Not
respect to this objective lens, not object.
not object. Objective lens.
Okay, fine. Okay.
whether it should be 7 minus 5 or 0.5.
Which one? V. V is 7 minus 5. That's what I explained here, right?
Okay.
Ashwara, tell me one thing. U is equal to minus 2/3. I mean, what is the physical significance of this thing?
No, U is the distance of object distance from the lens, right?
I mean,
This
I mean,
distance.
it's physical. So what is the significance? It's suppose U is equal to minus x. What is physically represents?
No, it is minus x means minus is not giving the value. Minus is which direction. See, from this objective, definitely your object will be the back side of the objective, right? So it will be
Acha.
considering that we have to know
Okay.
where we are keeping our object. Some lens cases, object is not the back side. We'll keep the middle of the objective and eyepiece. So
Acha.
that situation we have to know where we have to keep, like from the while seeing the value, the back side or front side. For that only.
Oh, okay.
Angular magnification minus 15.
Angular magnification. Minus 15. Yes.
How much? Minus 15.
Yeah.
And what is the physical significance of this negative magnification?
That's also like where the image is formed.
No, negative, I mean, physical negative negative means something is reducing or something is decreasing. For example, if you take the concentration gradient in our next session, there is a diffusion, the concentration is decreasing. Okay, angular magnification negative means it is decreasing. I mean, what is the physical significance of this minus sign?
No. Um,
Suppose J is equal to minus D into dc dx.
no,
Okay,
no,
fixed
it is
formula.
not like that. Magnification means always it is like how many times from the objective size. Okay, but the sign is coming like the image is forming in up direction or down direction.
Okay, fine. It is coming on
Like
opposite. Okay.
no inverted or normal image like that.
Okay. Thank you.
Like normally for a negative magnification means the image is forming real, but the image will be inverted. That's it.
Image is forming.
Image is real image, but
Uh-huh.
and it will be inverted image. That inverted
Inverted
is showing
in by
negative
negative
by the
sign.
negative
Oh.
sign.
And what is this angular magnification means? I mean, what is the difference between normal magnification and angular magnification?
It is like what to say.
I mean, physical meaning क्या है? I mean,
Uh, that is actually with respect to our eyepiece. Okay, like our eyepiece will be in one. Um,
आईपीस तो ये माइक्रोस्कोप में है.
yes. Like if a normal case also with respect to our eye. Okay, wherever the vision is coming. Okay, from that level to how much it is magnified. Like from the objective normal size to how much angle it magnified. That is angular magnification. For
Okay, I'm
example,
not very clear. Okay.
just like
How many types of magnifications are there?
no, normal magnification is like we have to take the ratio of the objective length v by u. That is for a
Uh-huh.
visual lens. But for a eyepiece and all, the magnification is different. It will depend on the d value, least distance, as well as the v by u 0 and focal length also for a simple microscope. Each material it will be different in the magnification. Like each system. Compound microscope will be that we know MO and ME. Okay.
For compound microscope, I mean, I'm just
It will be
simplifying it. For compound microscope, we have to use this angular magnification.
no compound angular magnification is just measuring the magnification from the point of angle. Like what to
The
say?
point of angle means?
Like see, if you think our eye is here, okay, hmm? and the object is here. So from here, see, this angle will be there, right?
Okay.
So
This tan theta is angular magnification.
not tan theta, only theta value. Not in tan theta value.
I mean, for smaller angle, tan theta will be theta. I
Same,
mean.
same. So normally angular magnification will be this is the theta value. Now the image will form in our eyes retina, right? So that
uh,
angle also will be there. And like image forming angle if you think theta dash. And the ratio will be there.
so angular, I mean,
Angular
can I
ratio. So that
Okay.
will be the angular magnification.
I mean, is it the measure of how much area we can see? Because if you take this as image plane, okay,
Hmm.
then it basically represents the area, how much area we can cover.
Like
Is it so?
oh, like this you're saying, like how much area.
I mean, am I right? I mean, just I'm trying.
I don't know. That is not an area kind of thing. Like if some object is here, okay, which is passing through and making an image here.
Okay,
Okay,
okay.
this angle is theta, where the angle is height. This angle means from the normal level to the height of the object. So that will be one angle. And here the angle is theta dash. So some cases magnification means it will be heighted, right? So theta dash will be
Acha.
different. So theta dash by
Uh-huh.
theta, that will be the angular magnification.
Okay,
In
okay,
terms
fine.
of angle, we are measuring. Normally, what we will do, V by U we will do, like the distance.
Mm-hmm.
But this is by angle also we can say the magnification.
Okay, okay, fine, fine.
That's it. Here only you have to remember for a compound microscope how it is getting complicated because optical eyepiece, two kind of lenses are there. So each lens will produce the same, like focal length will be there, each lens magnification will be there. So that should not be any confusion actually.
From which book it is taken?
Book I have to cross check. Like I
Because
think.
it is not in the Callister book. Okay.
Yes, yes, I know that. Okay, so there are two more formula actually. Two more problems, but formulas are same. Um,
Two more formula.
no, two more problems. Formulas are same for this, for compound microscope. So there are only three formulas like this: angular magnification is one, and normal lens formula 1 by v minus 1 by u. But you have to remember one thing: objective which act as a normal simple microscope. Okay, like microscope, how it will be only one lens will be there. So the image will be there and passes through it, and it will come focus somewhere. Okay, so that is this objective as it is a one simple microscope. I think I wrote all the formulas here. Good. So let us solve the next. Oh, I didn't write the answer. So we will get it minus 2 by 3. Okay, and angular this will be v by u times d by fe. So you will get 2 divided by minus 2 by 3 times 25 divided by 5. You will get minus 50. That's it. Now let us go to the next problem. The objective lens and the eyepiece used in a compound microscope are focal length 4 cm and 20 cm respectively. An object is placed at a distance r from the objective lens. What is the magnifying power and length of the compound microscope? So what is the magnifying power that we already discussed, right? M is equal to MOME for a compound microscope. And ME we written already 1 plus D by FE. So total M how you can written, and MO will be like a normal line. So it will be V by U. Okay. So the total M will be V by U times 1 plus D by FE. Okay. Now there is a lens basic formula 1 by v0 minus 1 by u0 is equal to 1 by f0. Okay, from this you have to calculate the V0 value. Which means here everything will be V0. And all other parameters are given. And for a compound microscope, this least D value will be 25. Okay, that is the general base, like known value. Least distance will be 25. So every time the compound microscope D value will be 25. Okay, and F is given already, focal length is given, and V value you have to find, U value is already given in the question. So you can find the magnification value. What is V0 value you are getting?
Done. 2.4.
V0 will be 2.4. F0 is what? Okay, 1 over V0 will be 1 over F0 minus 1 over U0, right?
Yes.
So it will be 1 over 4 minus 1 over minus 6.
So it will be 1 over 6 plus 1 over 4, right?
1 over 4 minus 1 over 6.
1 over 6. Okay.
It will be 1 over 12. So V0 will be 12.
Minus 7.
Yeah, minus 7. of the eyepiece. We'll have to add here. So it will be, length will be, you have to add the magnitude. Magnitude of E0 plus magnitude of UE. Okay. So V0 you found from here. What will be UE value? This is same, 1 by VE minus 1 by UE is equal to 1 by SE. From here you have to find UE value. So 1 by UE you can write it as 1 by VE minus 1 by SE. And 1 by VE is what? 1 by minus 25 minus 1 over 10. From there you have to find the UE value. This UE value you have to apply here. So here it will go. Tell us what is the UE value that we will get the length. How much you got UE value? Zero minus 7.1. So maybe let's say what will be it? So can you please try the next problem? The same formula. Whatever you are using, same formula you have to use here also. So the objective lens and eyepiece used to cover microscopes at focal length 2 cm and 3 cm respectively. The distance between the objective and eyepiece is given. So L is given 15, F0 given 2, FE given 3. Now you have to find the distance of the object and image produced by. So V O you have to calculate, U O you have to calculate. So it's like here the U L value is given. So L value is given means L will be what, V O plus U E, right? But here the final image is formed at the infinity. So I told that earlier one criterion, like if the final image is formed at the infinity, then only we can least distance we can see. So like very least distance we can see the image. So then your UE will be FE. Then you can write it as VO plus FE. Okay. So our VO will be.
Can I repeat it once again?
Yes, like earlier problem. Like I told like the least, the eye is least strained when the final image formed at the infinity. If the final image is forming at the infinity means what we have to do? The two length. Here.
For no strain, for no strain, image formed by the objective will be at the focal length of your eyepiece.
Yes, the same thing. Same only here also. Such situation, what will happen? The image will forming at the infinity. The final image will form at the infinity.
In both cases.
Yes. In the least strain case also, you have the image should be in the infinity, and here our criteria is the image is formed at the infinity final image. Then what will happen? This UE value, that eyepiece objective value, and the
So then the situation will be analogous, no?
One is physical situation, the image is formed there, like that. Okay, for that we have in mathematically what we can limit. When image is forming there means these two lengths will be same, focal length and the image formed by the objective also should be same. So here also we have to use the formula 1 by VE minus 1 by UE is equal to 1 by FE. So 1 by FE is equal to 1 by VE minus 1 by we need to find 1 by UE. UE is equal to 1 by VE minus 1 by F. So the image formed, final image will be at the infinity. So VE will be infinity minus 1 over 3. Okay. So your answer will be UE will be minus 3. Okay, so that is same as FE. So what we are taking is, then we are going to get the value VO. VO will be here. So the length minus the magnitude of this value. So it will be 3. So the length is 15 minus 18 minus 3 will be 12. So V0 value is 12. From the V0 value, 1 by V0 minus 1 by U0 is equal to 1 by F0. From there we have to calculate U0 value. That's it. What is the U value you are getting? So for today's class, the basic things which we have discussed is this. Okay, so normal, what the compound length, how it will work, and
Yeah, एक बार solution एक बार तो दिखा दीजिए ना. Can you show me the solution once again last time?
yeah,
Last problem.
yeah, sure, sure.
Minus 2.4.
Minus 5 by 12 will get.
No, fine. Thank you.
Yeah, so just remember few formulas, that's it, okay? Then you can solve all the problems here. So first one is that class what are solved all these formulas, and we solved two problems related to that resolution problem. Okay. That's the first formula. Then this value, resolving power formula, the second formula you have to learn. And the third formula will be these three. Third set of formula, M value, ME value, MO value. So total 5 formulas you have to remember, then you can solve all the problems. Okay. I hope you understood something. Hello.
Yes, ma'am.
Please go through the assignment problems more carefully, and try to finish the assignment first. And while doing assignment problem, just cross check with the units. That's it. Okay.
Yes.
Yeah. So
But
shall we?
for assignment two, already the due date is over.
I think you already solved, right? Like this only.
Yes.
And
Yes, ma'am. Solved.
yes. But for solving assignment, listen fast class very carefully. Then you can solve it almost every question. Every question only will be the problem, because even the single word what he is saying, that also will come in the assignment. That's it.
Okay.
Yeah.
Thank you.